Greetings there, 8th graders. This is Mr. Rogers, and we're going to be doing a quick review of your ISN for star stuff for folks that are looking to get a little bit of extra insight into how to build up their ISN pages. So we're just going to go through the pages. Hopefully this is helpful to you and you can get something out of it. So obviously on your first page of your star stuff, you'll have the table of contents, which you can see right here. Make sure that you indicate the big ideas, and I've taken a couple minutes to type those in right here. Remember, big idea A is that the sun affects us in every aspect of our lives in lots of really unusual ways too, as you'll see in the next few pages. Then the second big idea is that stars are giant atom factories, that inside they put atoms together, small ones, to make bigger and bigger atoms. And so really stars make atoms. And big idea C is that we are all made of star stuff. That we are a way for the universe to know itself. And of course, these questions go with that. So with that, I'm going to jump ahead to the next page. This would obviously be page 1 in your ISN. And here we have just some simple definitions. And you'll have to forgive the handwriting here, but this is what we captured in our last class. So with sunspots, remember that they're dark spots on the sun, that they're cooler than the rest of the sun. They are strongly magnetic, and they follow an 11-year cycle. Solar flares occur in conjunction with sunspots, and these are sudden increases in brightness that happen right next to the sunspots, and these will shoot out, hit the Earth, and cause the northern lights, and they will fry satellites too. Solar prominences, this would be what you normally think of when you think of the sun, all these like flames, it looks like flames shooting out of the sun. And here a solar prominence is really gas that loops out from the sun and then gets pulled back in and crashes back into the sun. And solar prominences are highly magnetic. The solar wind would be this right here, this definition. It's a steady stream of electrically charged atoms, which of course would be ions that are streaming out of the sun in all directions. These first three are like eruptions. This one right here is a steady constant stream. And then the very bottom one here, which is cut off just a little bit, it's a coronal mass ejection, or CMEs. And those are sudden bursts of solar wind that break away from the sun and never come back. And what I'll try to do on each of these pages is also give you some suggestions on some right-sided activities. So for this right-sided activity, I would recommend an illustrated dictionary entry for these things, so you draw pictures of them, or concrete spellings, which I think would be really creative too. Then the next page, still on question A1, in what unexpected ways does the sun affect the Earth? And here you can take your sunspot graph that you created in class and tape that in on the left side. And on the right side, I would recommend a caricature. And we even did one in class here. So like for me, I did a roller coaster because that's what the sunspot graph looked like. And I put the sun on it with its spots. And so here it's at the sunspot peak, and then it comes down here about half of a cycle later, and very few sunspots. So I tried to do a caricature of the sun relating that. But again, you can do it however you want. Then the third and final page for question A1 is, in what unexpected ways does the sun affect the Earth? And we did this crazy worksheet over here. It was pink at the time. And as it turns out, we found out that all of these different things that also follow 11-year cycles can be traced back to the sun. The sun impacts our technology, our cell phones, satellites. It affects our weather and causes many droughts, which can impact kangaroo populations, rabbit populations, certain beetles that rely on crops. They trigger the northern lights. Solar flares obviously happen right along with sunspots. And so then some of the weirder ones, like the output of cars produced, if the sun is impacting us in droughts and things like that, it's impacting us economically too, because droughts can impact the price of food and how much people are spending. And so as it turns out, the sun affects us in lots of ways. So the activity over here, I'd suggest a cartoon kind of relaying this information, or perhaps a texting or a tweeting exchange between perhaps the sun and the Earth to kind of explore that a little bit. And then if you remember, the next three questions, B1, B2, and B3, we decided really do fit in very nicely on just one page. And we did the atom review. So you should have your atom review notes right here, which you can just attach on the left side. I would recommend a mini mind map to kind of help you piece together all the parts of an atom. And I don't know if I can do this justice here, but if I turn this around and make this a little bigger, maybe we can see some of this right here. You can also, and this might be a better thing, come in and see me, and we can talk a little bit more about this if you don't have these notes. But atoms, they come with three parts. You have protons, which are positive, located in the nucleus, neutrons, which are neutral, and they're also located in the nucleus, and electrons, which are negative, and they orbit around the outside of the atom. So you can see protons and neutrons with the electrons going around the outside. And in a normal atom, protons and electrons are always equal to each other. Over here we have ions, and ions are atoms that just have the wrong number of electrons, that either gained or lost electrons. And so that means they're magnetically charged too, because here we have a negative ion, which has 3 electrons and only 2 protons, and normally it should be 2 and 2. So it has too many. It's picked up an extra one. Over here you have too few, and so this actually makes a positive ion, because here you have 2 protons and only 1 negative electron, which leaves you with a positive ion. So here an electron must have gotten knocked away. Isotopes, kind of the same situation, but they're an atom that has the wrong number of neutrons. It's either gained or lost neutrons. So here you can see a sketch. It's a little fuzzy here just in the scan that I did, but with too many neutrons or not enough neutrons. And then atomic number is very simply the number of protons in an atom. And so if I told you the atomic number of carbon is 6, it has 6 protons. And you can also safely guess the number of electrons, because protons and electrons in a normal atom are always balanced and equal. Atomic mass, that's just protons plus neutrons. And so if you know the mass number and you happen to know the number of protons, thanks to this over here, then knowing these two numbers can help you to know the number of neutrons in an atom. So if you subtract the protons from the mass, that'll tell you how many neutrons you have left. And so that, of course, then would be the atomic review that we did. Then the next page would be what makes stars shine. This would be question B4. We took some notes directly in class on this. We talked about fusion that's occurring inside the sun, and it's when 2 hydrogen atoms crash into each other and produce a larger helium atom by their combination, their fusion, and that produces energy. So you can see I did an illustrated dictionary entry of this definition over here. And you're welcome to do that sort of activity or do a different one. And then the next one is C1, C2, and C3. How are stars born? How do they die? And how are they like phoenixes? And of course, you did a graphic organizer, which is attached right here. If you want to review the information in here, I would recommend looking at the other 2 YouTube clips that go along with this review for the life cycle of a star, because there I actually went through each of these stages and narrated that. So you can take a look at that in more detail. And you might want it just as a review for your final project too. But if you're looking for an activity over here on the right side, I'd recommend a diary entry or perhaps another tweet or text going on here between stars perhaps. I think a diary entry would make a lot of sense if you're thinking of doing, for example, a star story. And then that leads us to the very last page, which is C4. What patterns do you see in a star's size, color, temperature, brightness, and lifespan? So we just brainstormed in class after looking at the HR diagram and learning a lot about stars, and we realized that small stars are cool, they're dim, they're red in color, and they live an insanely long time. Large stars, however, are kind of the opposite. They're hot, they're bright, they're blue, and they have extremely short lives. So, and then all stars have this in common. They begin and end with a nebula. They all begin as a main sequence star, and they all fuse hydrogen. And I would recommend a song tie-in. So maybe grab your favorite song, and if you see the connection in the lyrics, print off your lyrics, put them in here, and then just on the margins write how it relates to the page over here on the left. So that's your review in a nutshell of all of the ISN for star stuff. Like I said, if you're looking for more detail on the life cycle of a star, I've got a couple other YouTube clips that go into much greater detail there. So good luck in your quest to complete your ISN, and can't wait to see them. Bye.